All right. Okay. All right. So what I want to do first, I want to do an example that was similar to the one I threw out on the exam. I mean, the exam question I threw out, it wasn't a bad question, but I thought it would be better to not have it on an exam, mostly because the polynomial I gave you, it would have been a lot better. It's easier to just factor by grouping in that case. Also, I thought the directions were a little off in that one. So let me just do that one. Let me do a similar one here. Okay. Also, again, you know, if you forgot to hand something in, you know, like a homework or whatever, please contact me, okay? You can work something out. I understand, you know, things happen. I understand that. You know, this is an online environment. It's not what any of us expected, okay? Also, that does remind me, I did post it on the announcements, but there will be a homework and quiz available today. The homework is due next week, and I think the quiz, if I remember correctly, is due on Thursday, I want to say. The due dates are on there, though, so, you know, just letting you know. All right, so for this one, okay, synthetic division. So let's do this example now. So it is known that this polynomial has 3 as a root. We're going to use synthetic division to factor it. So since 3 is a root, what does that really mean? Well, it means that f of 3 is 0. So if I took this 3 and plugged it in for x, I would get 0. So f of 3 would be 0. Then by the factor theorem, that tells us x minus 3 is a factor of f of x. X minus 3 is a factor of f of x. So in other words, if I took this polynomial and divided by x minus 3, if I divided by x minus 3, right, I would get a quotient and I would get a remainder of 0. That's what would happen. I'm going to use synthetic division. I know some people on the exam used polynomial long division. That's fine. That's fine. I mean, synthetic division is a special case of it, but I did say also that if you use the method slightly different than what I did, that's fine. I'm not going to mark it wrong if it's right. So, you know, I didn't teach polynomial long division, but again, if you want to use that, that's fine. And if you don't know polynomial long division, that's fine too. So anyway, for 3 here, right? So for synthetic division, right, we have 3 goes here, right? The coefficients of the polynomial, right, we list those. We have 1, 8, minus 5, minus 84. Any missing intermediate terms, you would just put a 0 in as a placeholder. So if, for instance, the x term was not here and we had 8x squared minus 84, we would put 0 where minus 5 would be. Okay, if the x term was not there, we would put a 0 where the minus 5 is. That's what we would put. Okay? All right. So for synthetic division, the 1 comes down, and what did we do? 3 times 1, right? That product, which is 3, goes here, as illustrated here. 3 times 1 is 3. That goes here. Next, you add 8 plus 3, right? That's 11. That goes here. 8 plus 3 is 11. That goes here. Okay? Right? 8 plus 3, that's 11. That goes here. Then we repeat the process. Namely, 3 times 11, right? That's 33, that's going to go here, as you can see. I mean, if we were in class on the board, what I would do is I would write down, the steps. But here, I can't write it up by hand, so that's why I'm showing all these steps here, so that everyone understands. So we have 3 times 11, 33. That goes here. And again, what goes down here? We add to get 28. So again, we're repeating. It's a process we keep repeating. So we have 3 times 1, that's 3. 8 plus 3 is 11. 3 times 11 is 33. That goes here. Then negative 5 plus 33 is 28. That's here. As you can see. What goes here? 3 times 28, which is 84. As you can see. And negative 84 plus 84, we know, is 0. And we should expect the last number here to be 0, right? We know x minus 3 is a factor of the dividend, which in this case is this polynomial. And to say it's a factor means if you divide, you get a remainder of 0. And that's what happened here. Okay, that's good. And now what happens next? Well, remember here, right? These numbers are the coefficients of the quotient. And the quotient's 1 degree less than the dividend, which is f of x. So since this is degree 3, the quotient's going to be degree 2. And the coefficients of it are 1, 11, 28. So we get x squared. So the coefficient is x squared, or 1x squared, plus 11x, plus 28. And as I said before, the remainder is 0. That's what we get here. All right, that's good. Awesome. And so we know then from division that the polynomial here is x minus 3 times the quotient. Okay? Normally we would have plus a remainder, but again the remainder is 0. And now really the hard part is done. We want to factor now, we can factor this. And for this, we're not going to use synthetic division. Okay? So if I did put this on a final, I would be more specific in the directions. I would say, when you get down here, the quotient, you don't have to use synthetic division on. Okay? I mean, you could use synthetic division on this, but then you would have to guess what are the roots, although I guess you could do that using the quadratic formula. But anyway, let's factor this, though, using what we know from earlier in the course. Okay, we have a trinomial. This is over here. The leading coefficient is 1, right? So we want 2 numbers whose product is 28 and whose sum is 11. The product's 28, sum is 11. All right, well, what 2 numbers are going to do that? Well, how about 7 and 4? 7 and 4. Okay. 7 times 4 is 28. 7 plus 4 is 11, right? So that's what we have. Okay, so now we factored our quotient, okay? And now we just substitute and we get this thing is completely factored. So this really shows us another very nice application of polynomial division. Synthetic division is a special case of it, we can use it to help us factor. That's what we can do. Okay. Any questions on this? So any questions on this? Okay. Ready?